I'm Dr. Felice Gersh, your integrative OBGYN physician. So what did I want to talk about today? I want to talk about a pharmaceutical that actually acts as a peptide receptor antagonist. Now, an antagonist means it's a blocker. So it's blocking the action of this peptide on the receptor. So peptides, which can include certain hormones, like insulin is a peptide, they work in large measure. This is not complete, they're very complex, but in large measure, predominantly by binding to their receptor. Now, it's not really the greatest analogy, but kind of like, well, the key into the lock, right? Where the lock is the receptor and the key is the peptide. So the lock is not going to work without the right key, and the key is not doing anything without actually fitting into the lock and then turning it and making things happen, like open the door, okay? So, well, what particular peptides am I talking about here? Well, there's a pharmaceutical that came on the market not terribly long ago for the treatment of menopausal moderate to severe night sweats and hot flashes. Now, I don't typically do this, but I'm going to read the abstract from a recent article, recent meaning last month, April 2026, that this article was published. And to me, it's just a warning of using peptides, peptide antagonists, peptide agonists. So an agonist is something that would be turning on or acting like the peptide. So if it's an agonist for a receptor, it would act like the real thing on that receptor, the real whatever it is, peptide, to turn it on if it's a pharmaceutical. And in terms of an antagonist, that would be a blocker if you're talking about blocking the receptor. So the drug that I'm talking about, the brand name is Veozah, and the generic name is Fezolinetant. Let me say it again. It's always tricky for me. Fezolinetant. Okay, Fezolinetant. So this particular drug, like I said, is for treating night sweats and hot flashes of a moderate to severe degree in perimenopausal, menopausal women. Now, so this is my concern. It's about non-benign, which would mean the same as malignant tumors. So I'm going to hold this up. This is the article, and it's actually free in terms of the total article. It's open access, so any of you out there can access this article and read it at your leisure. So I'm going to hold this up. Okay, so if you want to take a little picture of it, you can take a little picture, and so I'm going to just quickly read through the abstract, and then I'm going to talk a bit about it. Okay, so the title of the article is Potential Risk of Neoplasms, that's like tumors, with Fezolinetant, Clinical Evidence, Mechanisms, and Post-Marketing Implications. So this article, like I said, was published in just April 2026. Now, it says, in 2023, the Food and Drug Administration, FDA, and the European Medicines Agency, EMA, approved Fezolinetant, Veozah in the United States, and it's Veozah without an H in Europe, a novel Neurokinin 3 receptor antagonist and first-in-class non-hormonal drug for treating moderate to severe menopausal vasomotor symptoms. While its efficacy and safety have been demonstrated through the Skylight and Moonlight programs, concerns were highlighted regarding a potential increased risk of neoplasms. Although regulatory agencies initially dismissed that risk, emerging data from meta-analysis and pooled analysis consistently showed a significant increase in the risk of non-benign neoplasms. These findings raise important questions regarding a potential causal link between NK3R, that's neurokinin 3 receptor antagonists, and cancers. So the initials for neurokinin 3 receptor antagonist is NK3R. By blocking NK3R, Fezolinetant can reduce Kisspeptin secretion, a ubiquitous, now they're talking about Kisspeptin, a ubiquitous peptide known for its anti-metastasis function. Furthermore, NK3R blockage may induce compensatory activation of the neurokinin 1, NK1R, that's the initials, which has been implicated in tumor proliferation, angiogenesis, and metastasis. Because of these mechanistic concerns, long-term safety studies and investigations of the NK3R pathway are essential to clarify the neoplastic risk of Fezolinetant. This review is based on a PubMed Medline search using specific keywords, etc. So what does all that mean? It's saying that this particular peptide, okay, neurokinin B, can potentially, if it's receptor 3, if the receptor called number 3 is blocked by a drug, which in this case it is, that might lead to a downstream effect that could potentially increase cancers. And what is this proposed mechanism? Well, it could end up down producing lesser the production of a different peptide called Kisspeptins, and also may actually act to impact a different receptor that's for the neurokinin, which is neurokinin 1. So what it said about neurokinin 1 is that the blockage of the receptor for neurokinin 3 may induce a compensatory activation of the neurokinin 1 receptor. In other words, if you block the receptor for the 3, you may turn on more the receptor for the 1, and maybe it will bind more into the 1. And the 1 receptor may increase the risk for cancer, and downregulating the production and function of the Kisspeptins may increase the risk of metastasis and other activation of cancer pathways. Because what it said, just to repeat, that when you block neurokinin 3 receptor with this drug, you can reduce Kisspeptin secretion. So what are these different things related to? Well, Kisspeptin is a different peptide that's part of a sort of family of peptides that are in the hypothalamus of the brain, and they're called the Kindi neurons that produce the Kindi neurons produce these neuropeptides, peptides from the nervous system in the brain. These are coming from the Kindi neurons. It includes dimorphins, the Kisspeptins, and neurokinin B. So neurokinin B has more than one receptor it can bind to. So it can certainly, we know, bind to one called 1, and it can bind to one called 3. Okay, so see how complex it already is? When you block the receptor for one peptide, you may block the production of another peptide, and you may then accelerate or exaggerate the reaction or binding to a different receptor for one of those neuropeptides because the other receptor is blocked. It's like if you can't go down in this direction, well, you get a backup and then you go in this direction. Well, it turns out that by blocking the receptor for neurokinin 3 with this pharmaceutical, you may then decrease the production of the Kisspeptin, which is a different peptide, but part of the same group of peptides produced by these neurons called the Kindi neurons. The Kisspeptins, by being decreased, can increase the potential risk for metastatic disease, activation of cancer, and having cancers being more aggressive. So it turns out that there's a lot of research on the Kisspeptins, which are part of the reproductive system in the brain, involving the production and release of these little hormones called releasing hormones that work to activate the pituitary gland to make the hormones FSH, follicle stimulating hormone, and LH luteinizing hormone, which help the ovary to have its natural rhythm and cycle and ovulate. But nothing does one thing in the body. That's the important thing to understand. These are peptides that are involved in reproduction, and they have receptors in areas that involve reproduction. But they're not just doing one thing. They do other things. So it turns out that kisspeptins, which may be down-regulated in terms of its production by this drug, Fezolinetant, may actually then increase the risk for more aggressive cancers, reactivating cancers that may be dormant, making cancers more aggressive. But this is not for sure. I want to make this clear. That's why the article is saying there are worry signs. They're not definite. I don't want anyone taking this drug to say, oh my God, this is going to give me cancer. I'm not saying that. This is an article saying there are worry signs. But the main reason I'm bringing this up is for all of you out there who are thinking of using all kinds of peptides that are so readily available now, to maybe think a few times over, at least twice, before you start putting peptides in, because of the unintended consequences that nobody really knows about. And the only way that we can know these things is if especially if they're not common sequela, is for large numbers of people to be using them, and not just over a short period of time, over a long period of time, thermoregulatory centers in the hypothalamus. Well, they also exist elsewhere in the body. So neurokinin B doesn't just work in the hypothalamus of the brain. There are also receptors elsewhere in the brain and also in the intestinal tract and elsewhere in the body. So in the intestinal tract, we know that there's a potential risk that if you block that receptor, the neurokinin 3 receptor, that you can have an effect on the liver. And all of these peptides have actions beyond just one spot in the brain. That's the important takeaway. I want you to know, peptides don't just do one thing in one place. If you give a peptide, you may have reactions and activation of receptors in the parts of the body you didn't intend to activate, leading to all kinds of imbalances. You're going to then affect a different peptide or a different receptor for a wholly different peptide. So you can see, just by looking at this one pharmaceutical and the questions that have now been raised about what is going on when you block this one neurokinin 3 receptor, it can upregulate and overactivate neurokinin 1 receptor. You may downregulate the production of a different peptide called the kisspeptins, which have the potential to increase cancers. And the cancers they're talking about include a whole variety of cancers, including melanomas and including different reproductive cancers and lung cancers, different kinds of cancers around the body. But none of this is proven. This is possible by looking at different registries and so on, both in the United States and in Europe, where this drug also is now available on the market. So the question is, what are we doing when we're modulating receptors of peptides, when we're giving peptides? Well, the answer is maybe good, but maybe there's also some potential for bad. Every drug has a risk and benefit profile. That's why it's so important to know not just the potential benefits, but the potential risks. Sometimes those potential risks don't become manifested for a long time if their risk isn't going to sort of manifest in very large numbers of people. So it takes a large number of subjects on that drug before you suddenly realize that this can happen. Now, even if the risk is very small, if enough people are using that drug, then a lot of people will have that adverse outcome. So please think about the complexity of taking peptides, how taking one peptide can potentially impact a domino effect on other peptides, production, receptor function, with all kinds of activity you may never know about until down the road. So I'm not saying you should never use this drug. You know I love hormones. So except in rare exceptions, which are rare exceptions, I would always use human bioidentical hormones. But for someone who has the exceptional situation where they can't take hormones, there could be a place for this drug. All I'm saying, if that happens, we should all be on alert that maybe this person has an increased risk for certain cancers, maybe. And that's important to know. As you know, there are many drugs that can be life-saving, that if you read the warnings, it can include death, it can include severe infection, it can include cancers. So that doesn't mean people can't use those drugs. A lot of those drugs are the biological immune modulators that have revolutionized the treatment of autoimmune disease. So I'm not saying these drugs should not be used. I'm just saying they should be used with caution and wisely, and always being aware that there may be, especially in a new drug, just out for a little bit of time, if something doesn't happen too commonly, there may be adverse events down the road that we discover quite a ways down. And when you think about taking peptides that are now available, but maybe not, they're not regulated, they have very little human data. There's no black box warning because we don't know enough even to put a black box warning on them. But there may be lots of side effects and potential risks because of all this complexity, because these peptides are doing things all over the body, different places, and they can have adverse effects, and we don't even know about it. So just a word of caution. Don't think that the word peptide equals better health. It's just a chain of amino acids, and how it is used in a medical sense really needs to be well researched before it gets on the market. And for drugs like this one, Fezolinetant, we need to have post-marketing data to ensure it is truly safe. We already know that that particular drug got some, concerns about liver health. So we definitely want to be cautious. And please don't just rush off and start taking peptides. There are a lot of questions we don't have answered yet about them. So my advice is work on macro management, not micromanagement. Peptides are micromanagement of cells. Macro management is eat the right foods, get enough sleep, exercise, avoid toxicities as much as you can, work on stress, make sure you have adequate sleep, and get the proper hormones when you need them, and get them in a way that's aligned with the way women who are healthiest would have them in their bodies.